Okay, good morning. My name is Victor, and I'm going to be your anchor for the CISCO CyberOps training. It's a 28 series training sections for Tier 1 SOC analysts. If you're interested in cybersecurity, this is one course if you have some basic foundation in web networks. So you can get into this course to better understand how you can defend, how you can protect your IT infrastructure, whether be it web or whether be it network. Okay, so we're done with module 1 to 9. And if you don't have access to the Cisco Learning Management platform, please make sure you do. You can contact us. You can let us know an account will be set up for you. You have a token so that you can have access to a more detailed view of these abridged slides. So the slides are for the instructor to be able to buttress the points laid out in the Cisco Learning Management platform. So we're in module 10, and 10 is network services. Now, there are quite some network services that run that ensures that we have good network functionality. And what are those network services? So you have DHCP, Dynamic Host Configuration Protocol. You have DNS, Domain Name Service. You have NAT, Network Address Translation, Network Address Translation. Then you now have File Transfer and Sharing Services, things like File FTP, TFTP, SFTP. All of those are file sharing services and protocols. Then you have email, where you have SMTP. Then you have HTTP, where you have hypertext transfer protocol, and of course HTTPS. So these are services that run on my network and they ensure network functionality. Bird's eye view. What's DHCP? So that's the guy that is responsible if I'm running a dynamics configuration type. That's to say that my IP addresses, I don't use them in a static manner. So I'm going to have a dynamic, or rather a DHCP server on a normal router. We do that. If you need to access the network through a router, normally what will happen is that you will send a message and say, please, I need an IP address so that I can connect. That's what happens on the background. Your router now does a check between you and looking at all of the IPs that has been assigned to other persons. It will look for one and it will map that to you. So you accept it, then you can be able to connect to the network. If you're connecting a phone, if you're connecting a PC, if you're connecting an IoT device or whatever to a network, it does things like checking IP address, verifying IP address, then it now connect. So it wants to make sure that there's no duplicate IP address. Then of course DNS is for local and web servers. Then you have NAT, network address translation. So that's what helps us to translate our local IP address and our public IP address. I've mentioned that in class before now, that your local IP address is that IP address that your router gives to you within your LAN or within your WAN. This guy is going to have 192.168.8.1.2.3, whatever. So that's what you use in communication with him. But your ISP is going to assign an IP to your router. So that means if you go to Google and type my IP address, you're going to see an IP address different from the one you have locally. So the one locally is what you call your local IP address. Then the one you get that you use to communicate to the outside world is called your public IP address. Now the question is that what does, if you're communicating from here to maybe somewhere else, what does the translation between your public IP address, or rather your local IP address and your public address system? That guy is NAT, network address translation. Then of course you have FTP, then you have email and HTTP. So let's look at them. I've just explained them. So you could have dynamic and you could have static, right, within your network. So for medium to large network, they can have a DHCP server. For home network, your router will do that, right? So your router is the one that is going to assign you IP address. And on your PC network configuration, you can decide to use dynamic and or static. If you decide to use static, that means the administrator, you will put in the manual IP address on the system so you can connect. But if you leave it at dynamic, which most people do, it's more easier to configure. You just need to go to your network on your PC, go to your different adapters, you right click and click on properties. If you click on properties, you will get click on the IP section. then you will see you can choose, you click on IP version 4, then you can click on dynamic or on what's it called, static. So if it's dynamic, the router does the assignment of the IP address. So how does the router do that? So it does that using DHCP discover, DHCP offer, DHCP request, right? So the first one is first discovers the client, uh, then it offers it an IP address, uh, then it does a request, right? So that's the, then the last one is the pack, right? If it's still available, it returns a DHCP pack. If it's no longer available, it returns a DHCP ANAC, not acknowledged. The first one is acknowledged. Then if the DHCP not acknowledged is returned, it resends a DHCP discover. So it loops the process again. The guy comes to the network, Mr. A. This is my DHCP server or my router. For large network, they can have DHCP server where they have hundreds and thousands of nodes on the network. That is PCs on the network, devices on the network, IoT devices on the network. So they will need to have a DHCP server to manage all of those IP addresses. But for a small office or a Soho network, right? What we just need is a basic router. The router will do all of those assignment of IP address to whoever that wants to connect to it to access the internet or access other networks. So I have my DHCP client. So it not necessarily will you say DHCP client. You can just say my PC or my phone or my route or my IoT device or my car or my gate or anything that is, or my IP camera that is going to connect to the DHCP server or the router. What it does when it comes to the network, it sends a DHCP discover saying, please, I need an IP address. This guy is going to scan on the IP addresses that it has available. For instance, it might have awarded 1, 5, 10, 20, 30 to somebody else. So it checks the ones that are remaining and picks one and assigns to this guy. It offers it one. If the guy says DHCP request, if this guy acknowledges it, then you are good to go. But if he replies with a DHCP not available, not acknowledged, what will happen is that we'll start the loop all over again. So that's how DHCP operates. Okay, these are some of the important things you should know. The fields in the structure of the DHCP message. What is it going to be picking? Your operation code, your hardware type, your hardware address length, how many hops you have between the network. Hops is like how many network before I get to that network where I have my DHCP server or router. Those information are very important, transaction identifier, and the rest of these guys. So it needs all of this information because the question is that that router is going to operate a CAM table, right? The router is going to have a CAM table. It's going to have a CAM and an ARP table, content addressable memory, and an address resolution protocol table. These two tables are important because it's going to hold all of this data so that when this guy is also needs to communicate with other persons, the router can facilitate that communication. DNS, you could just say ping softwareventures.com or ping cisco.com. You get a reply. So the domain name server will normally be something like ns1 dot that, for instance, for Southtech hosting it's ns1.southtechhosting.com, ns2.southtechhosting.com. So we've been hosting websites since 2010. So that name server, it's where all of the websites and applications that have been developed over the years are being stored. So if you ping a particular IP address on that server, it goes to the DNS server and picks out the name and of course the associated IP address. It then means if I go to my command line and say ping cisco.com, all of the replies I'm going to get is going to be coming from the domain name system or the domain name server. Okay, so this is hierarchy of domain names. So we have different, we'll call extensions, .net, .edu.com, .ru.co, and the rest. So this is what I just said. DNS lookup, all you get in reply is where is the website or where is the application domiciled, right? It sends you back that information. Okay, that's that. Same thing. So it's going to pick the IP address and return to you. To try it out on your CLI, you just type in cisco.com. It will reply you with all of the information. So don't forget, very important, that UDP uses port 53, right? If the data response exceeds 512 bytes, dynamic domain name system is used. Okay, so this is what the message looks like. I've explained this so you can read up. Um, who is very important. If you go to whois.com, I know when you were doing your forensic course also, or your web security course, your second module in the cybersecurity training, you learned about reconnaissance and footprinting, understanding that there is 5 hack process. So if a PC is going to be hacked, if something is going to be hacked, it's going to follow through a 5-step process. So the first one is reconnaissance and footprinting. The next one is scanning. The third one is gaining access. The fourth one is maintaining access. And the last one is clearing tracks. Now, the first one is reconnaissance and footprinting. So reconnaissance and footprinting, or like the military will call it recce, is that basic information gathering techniques that I do on my target to better understand that target. So who is fingerprinting, or who is um, uh, methodology, is one of the methods I can use to do reconnaissance. And if I go to whois.com, right, on the top search bar, I type a particular domain name, cisco.com, southtech.com, uh, softwareventures.com, I mean to say, and whichever IP domain name service that you love, what's going to happen is that it's going to return to you information like IP address, information about when the domain name was secured, was bought, when it's expiring, the location of uh, the host of that particular domain name. So this is made possible because of the GDPR regulation, the General Data Protection Regulation. So information should be, there should be freedom of information. People should be able to understand or know about these domains and who owns it and the rest, and of course their contact details. Okay, so there's a lab here with Wireshark. A NAT, so like I talked about, the internal network and the external or the internet address. So NAT is the guy that does the translation through a NAT router or your regular router, right? So what NAT does is that it allows our IP version 4 address to access devices and resources outside the local network, right? NAT, I've explained that. NAT works. So please look at the Cisco LMS. There's a short video that explains these things also using simulation. Don't forget, please. Take your notes. If you have questions, don't forget to ask on the mentorship group. And aside NAT, you also have PAT, port address authentication. They do same thing. One is port, sorry, yes, one is port and one is IP address. So NAT does for IP address, PAT does for port numbers. Just like I said, when you run TCP view, it's going to give you the source port, source IP address, destination port, destination IP address. So PAT is what does the translation so that you can know this guy and know where it's heading to. File transfer and sharing services. So that's what FTP and TFTP does, and of course SFTP. If you're a web developer or you're a network engineer, you might need to use TFTP to collect configuration files. Just very simple, basic configuration files of less than an MB. That's why it's called trivial file transfer protocol. But if you're a web developer and you are using uh, Dreamweaver, any FTP clients like FileZilla, Coffee Cup, and the rest, You will need FTP to transmit data between your system and your web server. So SMB, which is your server message block. So that's what helps us to describe the structure of the shared resources, right? Things like your printer, your network hard disks, and the rest. Okay, so this is it. So you have a lab that demonstrates Wireshark. How do you use Wireshark to examine TCP UDP captures, right? Email protocol. If you're configuring Outlook or any email client on your system, you will need the POP or the IMAP configuration. The IMAP if you're using a secured communication, and POP if you're using unsecured communication. So you're asking yourself, how do I configure Outlook or any email client of my corporate website? Let's say I have info at blah blah blah.com. I need to configure that on my Outlook. I just need to go to my host and grab the settings. So the settings is going to be username, info at blah blah blah.com, port number, it's going to give you the port number for this on that server, or if you're using this, it's going to give the port number on that server. Then of course the server is now going to be blah blah blah.com, and of course you tell it to enter your password. About five information you need to configure um, email protocols on a local host. Of course, another thing for your exam that you need to understand is that SMTP uses port 25, just like UDP uses port 53. Okay, POP, I've explained POP. So you have POP and IMAP. If you are asked which is more secured, right? So you answer IMAP, right? Uh, Let me see something, just a moment. Just a moment. I'm trying to reconcile the difference. Okay, I think that's fine. So HTTP, you have everyone who uses the website, uses the internet to browse. So HTTP is that protocol that we use to communicate. And of course, if it is HTTPS, so it's port 443. If it's HTTP, it's port 80. So you should be aware of that, please. So it just tells you how data is being transmitted. Okay, so what's the breakdown? What is the detail of uh, the HTTP URL? This first part is called the scheme or the protocol. So it can be HTTP, it can be HTTPS. If we're discussing FTP now, you could have FTP here, right? This is the domain name. You can even break this down further by saying this example is the what? TLD, top level domain name, whereas this is the domain name extension. So that means that you can have example.com, example.net, example.us, example.com.ng, example.co.uk, example.za, that is South Africa. So this is the TLD, top level domain name. This is the domain name extension. Port number is how am I communicating? Of course, this must correlate with this. So if this is HTTP, this have to be 8080 or 80. If this is FTP, this have to be 20 or 21. If this is SFTP, this have to be 22. If this is HTTPS, this have to be 443. Right? You should have an idea of a good number of ports, their port numbers and usage. And of course, this is a path, a directory within the server, right? Maybe a folder. So this is the query and this is the fragment you are sending. Okay. Also, that's why it's good for cybersecurity experts to explore a good number of areas in tech. It will help you understand most of the things you're doing. Like you see all of the guys here, these are all stuff that has to do with web development. right? If you're interacting with an API, application programmable interface, you'll be doing this a whole lot. But just on the surface, take this to mean my trying to understand code, code, code operations. I will need to create, I will need to read, I will need to update, I will need to delete. So that's what these methods summarize. I might need to create data, create an account, read, that is to view information. I may need to update. I also need to delete data from the database. So status code, you should familiarize yourself with this because of the exam. And also because in practice, when you do penetration testing, when you do vulnerability assessment, you get some of these things as response code. So anything you have that is at 100 level or 1 of something, they are more informational. 100 continue, 200, most of the times you're having a success message. So we're always trying to look out for uh, 200. For redirection, it can be anything in the range of 400. So 401, we're very used to 401. 401 is, sorry, anything in hundreds is informational, anything in 200 is success, anything in 301, for instance, is redirection. If you have a web server and you're configuring redirection, just not last week, 3 4 days ago, I got a domain for a company. A company had, for instance, blah blah blah.com, and they needed blah 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 dot another extension. So what I did was to purchase a fresh domain name from our servers and redirected the new one to the old one, right? So they just needed another domain name for the purpose of meeting some regulatory compliance. Then 401, something like page not found, or you trying, that's why it's called the client error. You trying to access a page that was not meant for you. 501, for instance, you have a server error. If you have bandwidth, uh, if you exceed your bandwidth, or in situations where uh, the server cannot take care of all of the request that is receiving. So you have something like a 501 error. So yes, I've explained this. So if it's 403 forbidden, 404 not found. So web developers are always used to this 404 error. If you visit the website and that page is not there, it returns you 401. If you visit the website and you're not supposed to be accessing that page, it gives you 403. So okay, is there anything important here? So HTTPS is the version that is secured. Okay, so you could examine this with a Wireshark, or you just examine through your manually. You're able to see how this data is being transmitted. Okay, I think that will be all for the module 10 of the Cisco CyberOps training. Please, these are the things we've learned. These are some of the new words. Please check up your Cisco learning management system. Read up, make your notes, prepare for exams. If you have questions, please don't forget to ask on the mentorship group, and I'll be there to answer you.